Hey there, guys. Welcome back. This is video lesson 20. It is officially Memorial Day at the Sakaro Crib. I didn't put it out there, but I gathered you guys knew that we would have a 3-day weekend. Memorial Day is a national holiday. That's why I didn't post an assignment today. I'm gonna actually, because it's a 4-day week, usually I give you guys a video. I give you till Tuesday to watch it, an assignment due Wednesday, and then in a video, and I give you to Thursday to watch it, an assignment Friday. So this week I'm gonna post tomorrow, Tuesday. You'll have till Thursday to watch the video and an assignment due Friday. So you only have one this week because it's a shortened week. I'm gonna do slope fields today. And then I was thinking next week we'll spend a little bit of time on use substitutions. And then I'd like to wrap it up. I mean, that's week 1 of 2 of the last 2 weeks of instruction. Mr. Scotto and the school district, the superintendent, said that after June 16th, there's no more instruction or assessment. So I'm cutting it off at June 12th, because that's a Friday. June 16th is a Tuesday. So your last assignment will be due that Friday. I'm asking you all to get everything in by June 12th because I'm going for my C-section on the 15th, unless she comes early. And I've explained this before, but I'll say it again. I'm your teacher till the end because the district and I feel it's what's best for you guys as far as grades, graduation, and all that jazz. So I'm hanging in there for you. So I need you to meet me halfway here, okay? Yeah, so we're gonna do slope fields today. I haven't really gotten any complaints on it. I don't know if that means nobody's done it or whatever, but so I'll do it today. Wait and see if I get any feedback. So I'd like to start out by finishing the do now problem, which was the homework for video lesson 19. And then I started you kind of sort of on example 1. So I would like to do that one, go over example 1, which was the other homework problem, and then maybe do 1 or 2 more depending on time, okay? And then I'll give you some more homework. All right, so that's the game plan for video lesson 20. And you guys know what to expect for the end of the year. So basically we'll do use substitutions starting, I'll say next week. You'll have 2 videos, 2 assignments on use subs. And then it kind of depends on what we're gonna do from there. Either I'm gonna do a review and a quiz, or I'm just gonna give you like an end of year, sum it up, something to do, okay? So let's take a look here. Let's review what we've been doing. Slope fields are the geographical representation of a general solution. The general solution is when you do what we were doing for the last couple of weeks, where you separate the variables, get your y dy's on one side, your x dx's on the other, and then you integrate, and it's the plus c. So when you have an answer that has a plus c, that's your general solution. When you plug in a point, an x and a y, and solve for c, that's a particular solution. You can graph a particular solution on here, by the way, which I'm going to show you today. It's a little tricky, but you can do it. But the entire slope field with all the dots is your general solution. Now, I know a lot of you have been doing what I've been doing and try to conserve paper as much as possible. So just to remind you, if you do not want to print these handouts and you're looking at these dot plots like what the hell, remember the easiest way to just do this is to look and say it goes up 2, down 2, right 3, left 3. Okay, so I'm gonna sketch this out. And I go up 2, down 2, and then I go right 3, left 3. There's no numbers on here, so I'm not gonna put numbers. And then there's just dots everywhere. So you have dot, 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 dot. There were dots here, here, and then you gotta fill them all up. And it's something that takes, I don't know, 30 seconds, 45 seconds. And you don't have to print the packet, all right? I know the packets are like 6 pages long and blah, blah, blah. I've tried to make this as doable as possible for you guys on your end. I know supplies are hard, stores aren't open, things like that. Money's tough. Some people's parents are out of work. So it is doable without it, okay? And literally that took me 30 seconds. So you guys can do it, okay? If you don't want to print packets or can't. All right, so I did quadrants 1 and 4. So let's finish this up. Let's start on this end. We already did the guys on the axes. So if I do, so I'm gonna, everything in purple will be what your homework was from video lesson 19. Negative 1, 1. Now remember, you take a point, negative 1, 1. So I'm working on this point here, and I'm gonna plug it into dy over dx. So negative 1 goes in everywhere I see x, but it's already a negative, so be careful, over positive 1 for the y. So minus a negative makes it a positive, so it's just 1 over 1. So you'd go up 1, right 1, because that's your slope. Give me one word for derivative, slope. Give me one word for slope, derivative. Very good. So if I go to this point, negative 1, 1, I'm now going to draw a little line segment that represents the slope at that point. So up 1, right 1. So you see how if I'm at this point and I go up 1, right 1, it would be like playing la la la, connect the dots to where I landed. And draw a little line there like I would if I just imagine going through that point that I landed at. Okay, let's try another one. Negative 1, 2. Again, the x is already negative, so it's minus a negative, which becomes a positive 1/2. So now I'm at the point negative 1, 2, and I would go up 1 over 2. Here I am at that point, and I imagine that I'm going to connect back to where I was. It's got a little bit of a not as steep slope. Okay, then I'm gonna go negative 2, 1. So I'm gonna make a new one over here. So negative 2, 1 is minus a negative makes it a positive. So it's positive 2, so it's up 2 over 1. So here I am at negative 2, 1. I'm gonna go up 2 over 1. So it's a steep slope. All right, and then I'm gonna go negative 2, 2. Minus a negative becomes a positive. So positive 2 over 2 is just 1. So I'm going to go up 1 over 1. Okay? Should look like a mirror image of the other side. All right, negative 3, 1 is minus a negative, will always be positive. So it's just 3 over 1. So it's a very steep slope. 1, 2, 3 over 1. It's pretty steep. Steeper than the other one was. All right, and then negative 3, 2 is here. So minus a negative will always be a positive. So up 3 over 2. So here I am at negative 3, 2. I'm gonna go up 3, 1, 2, 3 over 2. It's laying down just a little bit more. And there it is. Now some of you get the hang of this and you're like, okay, so it's basically a mirror image of this side and you just draw them in. That's fine. If you're not sure, I would need to see the work to give you partial credit, okay? All right, so down here is negative 1, negative 1. So we have minus a negative makes it a positive. So it's just 1, up 1 over 1. Nope, that's not right, because it's a negative on the bottom. I'm sorry, it's 1 over negative 1. So to be up 1, left 1. Okay, negative 1, 2 is minus a negative makes it a positive, which is, I'm sorry, I keep forgetting the negative. Negative, I'm sorry, it's 1 over negative 2. So up 1, left 2. So it's laying down a little bit more. Oh, I'm really not doing well. Okay, negative 1, negative 2. Up 1, left 2. Is like that. Sorry guys, I'm here at negative 1, negative 2. Up 1, left 2 means I'd be connecting to this dot. Okay, hold on one second. I have to wake up my family, which I'll explain in a second. Olivia. Olivia. I need you to wake up Daddy. It's 3:31, honey. You gotta start to wake up the sugar-lug. All right? I'm recording. So last night we put the girls in the same room together for the first time. So they're officially sharing a bedroom. It was okay till about 5:23 in the morning. And I woke up to my 7-year-old and my 2-year-old staring at me while I'm in bed. And Olivia going, Mom, Ophelia was gonna start to cry, so I helped her out of the crib. She helped her out of the crib. She put a stool next to the crib and helped the kid climb out, figure out how to climb out. I'm like, oh my God, you taught her how to climb out of the crib. So I stayed up from about 5:20 till like 9:30, and then Jimmy tagged in and he stayed with them, and I went back to sleep for a couple hours because, of course, we were moving rooms and doing stuff last night. So after we put the kids to sleep, we finished up. We didn't go to bed till like 2 in the morning. So it was so bad, so bad. Okay, so anyway, pray for me tonight. Tonight's day 2 of the saga continues. The girls sleeping in the same room. What shenanigans will happen now? We thought keeping her in the crib for now would keep her in the crib. Like giving her a toddler bed, she'd be up and out, and they'd be playing with toys and whatever, and it'd be like a friggin' sleepover. So that didn't go over too well. Jimmy's right back to sleep. Jim, you gotta wake her up, honey, or she won't sleep tonight. Okay, so -2, -1. A day in the life of Sakaro. So we have minus a negative, makes it a positive. So we have 2 over -1. So we're gonna go up 2, left 1. So we're connecting here. So I gotta fix that a little bit. Okay, and then we're gonna go -2, -2. Minus negative makes it a positive. So 2 over -2 is 1 over -1. So we're gonna go down here, up 1, left 1. There it is. And we have 2 more points. I'm gonna try and squeeze them in here. So we have -3, -1. Minus a negative makes it a +3 over -1. So we're gonna go up 3, left 1. That's a pretty steep sucker. And then the last one, -3, -2. Minus a negative makes it a +3 over -2. So up 3, left 2. And that one's not as steep. So as you can see, I kind of pointed this out before and wrote it down in the notes packet when we did video lesson 19. It makes circles centered at the origin. Do you see the circles? Okay, so this slope field represents the general solution of this differential equation. It's the family of all the answers.
Where is the snack breaks?
Bottom shelf of the fridge. They might be behind the leftovers. Ophelia. So this is every single answer to this possible differential equation, because the plus C means it's a general answer. There's a lot of general answers depending on which initial value you give. If I gave an initial value of, let's say, 1, 1. If I want to draw the slope field for the initial value of 1, 1, you would go to the point 1, 1, which is right here, and then you follow it along, okay? Like this. And here it is. The solution to 1, 1 would basically be this circle. That's the particular solution. Okay, if I wanted to do it for 2, -2, I would go down here to 2, -2, and you follow it along like a road map. You see? And that's generally how you would draw out a particular solution if you solved for C and an initial value. Okay? All right, let's take a look at the other homework problem. Did you find it, Liv? Yes? Ollie, did you find it?
Yes.
All right, well, I can't hear you, Brat. Okay, so I started out at a couple of different points here just to show you how it's going to work. Just pick it up and put it back in. Okay, sorry, Olivia's rummaging through the fridge and everything's falling out. Okay, so I explained to you by showing you 2 points at the end of video lesson 19 that y does not exist in this differential equation. There's nowhere to plug in a y. So the y's don't matter. It's just the x's, okay? So if I take the point 0, like 0, 1, and I plug in 0, 1, it's really only just 0. 0 plus 1 is just 1. So it's the slope 1 over 1. And there it is. If I plug in...
Happy Memorial Day.
You're such a brat. If I have the point 1, 0 right here, I'm really only plugging in the x value because there's only an x in this differential. So 1 plus 1 gives me 2. So it's up 2 over 1. And there it is. Okay? So now if I plug in the point 2, 0. Okay? If I plug in 2, 0, 2 plus 1 is 3. 2 plus 1 is 3. So now I'm going to go to 2, 0, and I'm going to go up 3 over 1. Okay? So now I'm going to try 3, 0. Okay? If I plug in the point 3, 3 plus 1 is 4. So it's very steep. 1, 2, 3, 4 over 1. Very steep. Okay, so now I'm going to try these other guys here. So I did, if I do all the zeros, they're just going to have a slope of 1. Does everybody see that? If I plug in any of these zeros, 0, 1, it's just 1. 0, 2 is just 1. 0, negative 1 is still 1. 0, negative 2 is still 1. Because if I plug in x as 0, no matter what the y is, if I plug in x for 0, they're all a slope of 1. So they're all going to look the same. Okay? Because 0 plus 1 is 1. Now if I plug in an x value of 1, here, it doesn't matter what the y value is. They're all going to have that same slope. Because 1 plus 1 is 2. Up 1 over 2. I'm sorry, up 2 over 1. See? Up 2 over 1. They're all going to have the same slope. If x is 2, doesn't matter what the y value is. They're all going to look like this because 2 plus 1 is 3. So I just copy it up and down the line. Doesn't matter what the y value is. If x is 3, they're all going to be very steep like that. All right, so I got to figure out the negative x's. If x is negative 1, what's negative 1 plus 1? It's a 0 slope. Here's my 0 slope. And again, that's for all the x equals negative 1. See the pattern now? Because there's nowhere to plug in y. Hi, Ophelia. She's still sleeping. Negative 2. What's negative 2 plus 1? It's just a positive 1. I'm sorry, it's a negative 1. Can't add, math teacher. Negative 2 plus 1 is a negative 1. So here I am at negative 2. Down 1, right 1. So they're all going to look like this. Y again. Why do they repeat on this one? Because there's no y plugging in. So the y doesn't matter. And the last one is negative 3. If I plug in negative 3 plus 1 is negative 2. So I would go down 2, right 1. So it's a little steeper. So these look kind of funny. They look like parabolas where the vertex is somewhere over here on the x-axis. Does everybody see that? The parabolas? If I drew a particular solution, it would definitely look like a parabola. Okay, let's try another one. Let's do the reverse situation. Let's do number 2. Okay, number 2, if I look at a point and I go to plug it in, what happens on this one? I only plug in for who on this one? The y value. So now the x's don't matter. It doesn't matter what the x is at all. Okay, it's going to repeat in the y direction. Okay, you see the y direction is left and right, the y-axis. All right, so if I start with 0, when y is 0, okay, what's 2 times 0? 0. So they all have 0 slopes when y is 0. So wherever y is 0, I put a 0 slope. Okay, let's try the next one. When y is 1, what's 2 times 1? It's just 2. So now I'm going to go up 2 over 1. So they look like this in the y direction. Okay, now if y is 2, 2 times 2 is 4. That's a very steep slope. So imagine going up 4 and over 1. See how steep that mofo is going to be? It's pretty damn steep. Almost looks like a vertical line. Almost look like a vertical line. Yep, now her eyes are open. If it's -1, 2 times -1 is -2. So we're going to go the opposite way than the positive one. So we're going to go down 2, right 1. And here we are. Act like you're playing La La La, connect the dots. And they repeat in the Y direction because there's no change with the X values. And then we're going to try -2. 2 times -2 is -4, so it's just like this guy, but a negative slope. We would go down 4, right 1. So it's pretty damn steep, like this. Almost a vertical line, but with a negative slope. So what does this guy look like? It looks like there's a horizontal asymptote at the x-axis, and it does something like this, or like this. So everybody see that? Okay, it looks like it's exponential. Okay, like e to the x or something like that. All right, what time we got here? 21 minutes. Let's try one more, and then I'm going to assign you a few for homework. How does that sound? Okay, let's try one where they both change again. Let's do number 3. So we'll do, we have an x, we have a y, we have a dy over dx. Okay, so this one we have to watch because it has an x and a y to plug into. So we can start with the point 0, 0. With 0 plus 0, it's just a 0 slope. So it starts out like this. Then I'm going to go 0, 1 and 0, 2. 0, 1, 0 plus 1 is 1. 0, 2, 0 plus 2 is 2. So at 0, 1, I'm going to go up 1, over 1. At 0, 2, I'm going to go up 2, over 1. Okay? Now let's keep going. I would. All right, so 1, 0. So 1 plus 0 is 1. Up 1, over 1. Okay, 1, 1, 1, 2. 1 plus 1 is 2. 1 plus 2 is 3. So here we go. Up 2 over 1. Up 3 over 1. It's a little steeper. So we see they get steeper as they go. So we have 2, 0. 2 plus 0 is 2. So up 2 over 1. It's like connecting there. And then she gets steeper. So you could just eyeball it. So we see that? Let's try 3, 0. See how I'm starting to get a little sloppy, but you can see what the pattern is. That's what I'm talking about. Let's try 3, 0. 3 plus 0 is 3. So this is even steeper than this one. 1, 2, 3 over 1. And then they get even more vertical. Okay. Let's try -1, 0. That's a -1. So if I'm at -1, 0, I go down 1, right 1. So it looks like this if I'm connecting to that point. If I go -2, 0, that means I'm going down 2, because it's -2, right 1. So a little steeper. Okay? So now if I go this way, -1, -1. -1 and -1 is -2. Down 2, right 1. Something's wrong. Hold on. 1, -1. Ah, what's 1 plus -1? 0. It's a 0 slope. Be careful when you do it in your head. See, I'm starting to do it in my head and I'm getting bad. 1, -2 is -1. Down 1, right 1. Okay, let's do 2, -1 is -1. 2, -1. Positive 2, -1 is positive 1, sorry. So you go up 1, over 1. 2, -2 is 0 again. 3, -1 is positive 2. 3, -2 is 1. Up 1, over 1. Okay? So you see, I gave enough points here to get full credit. Now I'm just doing it in my head. All right. -1 plus 0 is -1. So down 1, right 1. Okay? -1, 1 is 0. -1, 2, if you add them, is 1. Up 1, over 1. Okay, let's go again. -2, 0 is -2. Down 2, right 1. -2, 1 is -1. Down 1, right 1. -2, 2 is 0. So everybody see what's going on here? Okay, -3, 0 is -3. 1, 2, 3, right 1. Act like you're connecting it. -3, 1 is -2. 1, 2, right 1. Act like you're connecting it. -3, positive 2 is -1. Down 1, right 1. Okay, a couple more. -1, -1 is -2. Down 2, right 1. -1, -2 is -3. So it's pretty vertical in the negative direction. Okay? -2, -1 is -3. Pretty vertical. This is a funky looking one, huh? -2, -2 is -4. Almost like a straight line. -3, -1 is -4. Almost like a straight line. -3, -2 is -5, getting even steeper. This is what you call, when it has these zeros here, it's a slant asymptote. These are shooting up to positive infinity. And these are going down very steeply, very quickly. This is your slant asymptote here. Just a FYI, but you would need to know that. All right, so for homework, I would like you to try 4 and 5, okay? Let's try 4 and 5 for homework. I tried to keep this short, sweet, and to the point. Like I said, I'm gonna make this week a light week because it's a 4-day week and Memorial Day weekend and all that jazz. So let me write this down. Homework for video lesson 20 is to finish examples 4 and 5. So notice in number 4, you only plug in for the x. So we go back to something similar like number 1. The y's don't matter. You're changing in the x direction, so it's repetitive in the x direction. So you figure out 1, and then it repeats up and down. In number 5, we go back to, it's only changing in the y direction. That's like number 2. You figure out the first y, and then you copy it left to right, because the y is not changing. Okay, give it a try, see how you do. We'll do number 6 together and go over 4 and 5, and then depending on your feedback, I'll move on to U-subs. All right, my loves, have a wonderful day. Hope you're enjoying your Memorial Day weekend. It's not necessarily warm, but the weather's been nice, and it looks like it's just clearing up in time for me to finish. So take care, brush your hair.